on the other side of the shop you don't get to see very often here today. And what I've got laid out here is a really nice Webcor kind of console unit. Lid closes down. Thing's in amazing shape for its age, but kind of get inside of it here and you can see that little tube amplifier on the inside. It's got some loud hum when you turn this thing on, so more than likely this electrolytic capacitor here is shot. So we're going to just do a general overhaul of this thing. I'm going to replace the electrolytic here. May replace these audio coupling caps here as well. I'll pull out the tube tester, check the tubes on it. Let's see what else. Totally missing here under the undercarriage, you can see on the tone arm. There's no stylus at all on either side, and this thing rotates over between 78 and 3345, so that's missing, as well as when the table turns you can hear the bad grind in there. So bearings are dried up, needs a good lube job, and my guess is the idler wheel on the inside here that actually turns this table is dried up and is hard. That's very typical of these units. Show you, it's a Webcor Holiday Deluxe. Customer dropped this off at a local record shop and I picked it up a week or so ago. Kind of did a diagnostic on them, on it. Told them what I thought it was going to take to fix it, and they seem pretty vested in this unit, wanting to get it fixed and going. It's a really nice little unit, all self-contained tube unit. This little unit thing here closes up. That's an internal panel I had to take off to get to the tube section, but anyway, I thought I'd show you a little bit about it and show you as I go along what all I'm going to plan to do to it. Alright, just a little bit more in here. This capacitor has a band going around it, and if you can see way down inside of here, it is riveted to this chassis, which is actually, if you notice here, riveted to this board. So I'm not wanting to undo all of that. What I'm going to end up doing is using a pair of snips here and cutting this band off, and then once I've got it out of the way, I can get down in there and get that rivet out. And the chances of finding this capacitor are slim to none, but when I get it out, I'll look. I'll probably end up with just looks like this is maybe a 1, 2, 3, 4 section capacitor here. If I can't find anything to replace it, I'll end up just putting together discrete caps to make up the same values. But I thought I'd show you what I'm going to have to do. I started cutting it here just a second ago and realized, I should probably show this on the video. We'll get this thing out of here and I'll show you a little more. Alright, let's see what we've got here. So if we look at this thing, we've got a 60 microfarad, 150 volts, what the original was. You're not going to find those values these days. They're just not commonly found values. So what I'm going to use instead is a 68 microfarad, 450 volt. That's Nikon, really good cap. For the 40 microfarad here, 150 volts, I'm going to use a 47 microfarad, 250 volt. For the 20 microfarad, 150 volt, I have a 22 microfarad Nikon 350 volt. And for the 75 microfarad, 15 volt, I'm going to end up using a 100 microfarad, 16 volt right here. So those 4 capacitors are going to make up this new one. And we're going to wire it all up nice and neat if we can get it done in that way in here. Basically, I cut the old capacitor off here, the leads you can see here on the very end. So on here it tells me orange, red, blue, and yellow. What will happen, and then the black's common. So the negative on all these will end up going together. I'll basically end up mounting them in a little bitty square, tying the 4 negatives together, tie it to this black wire right here, and then I'll end up connecting the positive to each of these in the correct space. And I don't know if it'll lay back down in there, but it'll sit nice and neat here. I'll make a nice neat little package out of it, and we're going to do that real quick. Alright, let me show you what I ended up making. I just took it into the other room and put it on the bench and soldered it. But I basically took the largest capacitor here and the negative lead coming straight out of the top of it. And I came to the other three capacitors, kind of held them really neat here, close up tight. And what I ended up doing was soldering them to the negative. So all the negative leads come to one, and that's where this is. And then I've got four other leads here, 1, 2, 3, 4. 1, 2, 3, 4. Where I have the positive connections for these capacitors, and we'll end up wiring those in here to these things really nice and neat. I'll end up using some little wire covers, kind of like the yellow on this wire here, to keep it from getting near anything, and then we'll end up bundling this thing right down in here nice and neat. Stay tuned and I'll show you when I get it done. Okay. Ended up doing something I don't normally do, but I brought the soldering iron in here. This thing's just way too big to get on my desktop bench in there. And as you can see, my other bench over here is just piled a little full of projects. So what we need now are some heat shrink tubing. So that's what I'm going to end up using. And as you can see, just wall-to-wall bends as far as you can see here. Lots and lots of various components or whatnot. In here we have our heat shrink tubing. And if we bring this over here to the bench, lots of variety here, but picked this up somewhere along the way, and it's got a whole big selection of pre-cut heat shrink tubing. That's what I'm going to end up using. So we'll pull this out. Put the lid back on this. Kind of bring it back over here. Put it back on the stack. It's just kind of the way I keep things organized. I know I've told you about the other side of the shop some, but lots of different stuff. You can see here where I keep, all electrolytic capacitors, different ones, axial capacitors, power-related stuff, range drop caps, audio coupling caps, etc., etc., etc. But enough about that. Let's get back in here and get to fixing this thing. All right. What I've done now at this point is I've basically stripped these wire ends, and all 5 of them. And for many years I used these kind of strippers where you kind of close them off and you gauge how far you need to crimp and then strip it. And I always kind of laughed at these kind of units because they were pre-made to cut the right size hole. But most of them I had as a childhood like this were just cheap metal, not very good quality. And ran across these one day. It's a set of Greenlays, and they're extremely high quality steel, and these things do an amazing job. So highly recommend those. Matter of fact, since I've gotten those, I've rarely ever pulled these things out, and I used to go through a set or 2 of these a year. That's how fast I'd wear these out. So I've been running strong with these for a while now. I'm gonna get the heat shrink tubing. So what I'm going to end up doing is putting one of these over each little wire. Now, I'm not the best left-handed surgeon, but end up putting it over and sliding it way down. The reason you slide it way down is because when you get this part you're going to be soldering, I'm going to cut them off pretty short and solder them like this, but once you get the solder hot up here, this wire will start getting hot. And what you don't want it to do is the heat of this wire to cause your heat shrink to shrink tight right here. So you're going to want it as far down the wire as you can get it. Kind of push it down, do your soldering. When it's done, then you'll slide this back up and we'll use the heat shrink tubing gun, which I'll show you here shortly. I'm just full of tips today. So if you'll notice what's on the end of this wire here, it's kind of hard to see, but I'll get it focused. What I've done is I've pre-tinned these wires. So took each one of them, got it hot with the soldering iron. Once I got it good and hot, I kind of held the iron on one side. I would grab my roll of solder here, and I would kind of come from the other side and melt a little glob on and make sure that it, it soaked into the wire really good. And I left behind a little blob on each one of them, as you can see. Trying to get this to focus right here, here. Basically on the end of every one of these wires. So they're pre-tinned and kind of ready to go. So once I get this thing over there and start holding it in place, it won't take a whole lot to get the solder to stick straight to these things, and pre-tinning will help a whole lot with that. And I've done the exact same thing with this end. If you'll notice, kind of got each wire, just a little bit of solder going on each one of them, got it good and hot so that it's ready to accept. And if you notice, I cut all these wires off so they're fairly short, about 1/4 inch long each. Alright, if you'll notice, I've got, see way down in here, all 5 wires now have their heat shrink pushed way down on the wire, and this thing is ready to solder in. So going to go ahead and do that. I just wanted to show you the prep work. Alright, you can now see that I have the blue going to the 22 microfarad, the orange here coming over to the 68 microfarad, the yellow, if you notice, the black's going to the middle there, to the common of all of them. But basically you can see they're all soldered in. If you'll notice how I soldered them, let's see if I can get some focus on this. It's in a straight line there. One's touching the other in a direct straight line. They're not crisscrossed. And I kind of drew the solder along the edge when I did that, so I didn't end up with a blob or anything that would prohibit the heat shrink from coming over it. There's only one way to really get good at soldering, and that is practice, practice, practice. And I got about 30 some years of practice at this point. I won't say I've done it daily, but it's pretty darn close. We'll be right back. I'm going to go grab the heat gun. We'll see if we can do this live. So you can see what I've done is I pushed each of the pieces of heat shrink tubing way up onto the end here, so they're as close as I can get them. And then down here, I've got just a standard old cheap $20 heat gun. This thing will get hot enough to melt your fingers. But basically I'll turn it on and move the air gently a little bit. It'll start cranking. So as you can see, I'll turn it off for a second and kind of flip this over on the other side. Come back around. Alright. Always make sure I sit this thing kind of down on the concrete or on the ground or somewhere, because the end's very hot, and if you set it down on carpet it'll melt it. At any rate, we'll let this cool off just a second. As you can see at this point, and what I'm going to end up doing is putting a strip tie around these just to kind of make sure they're held pretty good by that soldering of the center post. But as you can see, it's a pretty nice, neat little package here, and sure in the world, guess what it's going to do? It's going to tuck down right here inside. This is going to go here, and the cover, let's see if I can find it. The cover for this thing will actually end up going back on top and screwing down, and we will have recapped that thing. However, before I get there, I'm going to replace these. These are some pretty standard 0.22 microfarad 400 volt AC, 0.05 400 volt AC, a 0.1 400 volt DC, and a 0.05 400 volt DC. These are the audio coupling caps between the stages, and what happens is if with age these things start breaking down, and they're designed to keep DC from going from one part of the amplifier into the next stage, and only allow the audio signal to pass. That's kind of what an audio coupling capacitor does. But what happens is they start breaking down. Not only will they pass the AC, but they'll pass the DC. And then when you start feeding DC into a plate of a, part of a tube, maybe the cathode of the next tube or whatnot, that wasn't designed to have DC sitting on it, it kind of messes with the whole tube bias, and it can start to deteriorating parts in there. So, at any rate, I'm gonna show you how I swap these out real quick. All right, if you remember, we needed a 0.22 400 volt DC, 2.05 400 volt DC, and a 0.1 400 volt DC audio coupling capacitor. So I came over here and I started digging through my little bin of lots and lots of audio coupling capacitors. And I'll tell you right now that 0.05, which there are two of, you're not going to find that value. It's just not common. .047 is the common value, but those are 630 volt Russian paper and oil caps. Probably not going to use those, similar Russian and oil. But I do have some .047 poly caps, so not extremely high end, just good solid units would work great in this. If you remember, I needed some .22s, probably going to use some of these. And then I needed some .1s, and I've got some other poly caps here. I've also got some orange drops here that would work, some 715Ps as the .1. And I've also got some .22 630 volts that maybe I pulled out of something before that were still in good shape. We'll figure it out, see what fits best, and we're going to get these things soldered in there. All right. I've snipped this .22 out. You can see one end's right here, the other end, the little lead's right here. If you'll notice what I'm doing here on the ends, I'm bending little loops on each end of this thing. What I end up doing is connecting these, kind of bending a loop back the other way. I'm using some little pliers here to pinch them really tight, and that way I'm not making a solder connection, I'm making a physical connection first, and then I'll solder on top of that. You've probably heard me talk about that in other videos, but not a big fan of just a solder connection holding things. Well, we're getting there, but as you just see, I've got to make this run from way over here at the middle wiper on this bottom pot with this 0.47 microfarad capacitor all the way over here to this space right here and connect together. And I just don't want that long piece of wire left laying out there, so I'm going to do two things. One, this stuff right here, it's wire cover. It's really thin. I'm going to cut a piece of it off and slide it over top of this, and I'll show you what I'm talking about. Alright, I've slid it over. You can see right here, it just kind of slides on and off really thin, about the exact same size of the wire. And what I'm going to end up doing is connecting those two together right here, but then I'm going to have this spot in the middle where it's kind of exposed. So what I'm going to do first is slide a piece of heat shrink tubing up over the top. And matter of fact, I think I'm going to go get a smaller piece of tubing. And you can see now I've got the two wires soldered together good and tight here. Got the plastic sleeve there. Now I'm going to slide this piece over and grab the heat gun again. Hang on a second. Alrighty. Okay. And guess what? We now have this one soldered in, middle wiper down over here. Soldered it in just the way it was originally. This one similarly coming off this part of the tube, coming down here. All four of those things are tucked nice and neat down in there. This resistor kind of bent back over, and I put this 0.22 microfarad cap in place right where the other one was as well. So we are done with the recap job on this thing. I'm gonna put it back together and turn it on and see how it sounds. Well, just thought I'd talk about a couple things because I got to thinking about it a while ago. Before I close this thing up, there's one more thing I want to do. But first off, people may ask, well, hey, you went through there and replaced the resistors, the capacitors. Why didn't you replace all the resistors? Well, here's the deal. Resistors will drift in value over time, especially these old carbon type. But they rarely go bad, per se. They may drift off value a little bit, which sometimes can hurt the circuit, but most of the time, not so much. If they go bad, you'll know it. Usually you can see they're charred or brittle, and you tap on them with something, they'll break in half or whatnot. And I usually do check resistors when I'm working on something like this, just to make sure none are damaged or anything. But that's why. Usually the caps, these are electromechanical device, electrochemical device. Over time, they actually dry up and go bad. So that's why I replaced all the caps in it. And only if I have a problem after that would I go in and actually start checking resistor values or whatnot. But the final thing I want to do, if you'll notice, see this potentiometer? See down here the little where the board goes in from the wiper blades? There's an opening there. Similarly here, same on that one, same on this one. I'm going to hit it with a can of deoxit D5 just to clean all these controls, because once I close this lid back up, and put the cover back on, you would not have the opportunity to do that. I will give you a warning, deoxit D5 is not a cure-all for all things, so be careful what you're using it on. Most potentiometers you're okay. If you get into slider controls on a unit, like maybe on the front of a Marantz or something, you want to get something besides this. It can be a little bit harsh on those things. So, and sometimes I just use good old contact cleaner as well. I'm going to jump in here and get this thing cleaned up with some deoxit. Thought I would show you here. See how I get the little red nozzle right down here into the, almost inside the potentiometer here. Give it one good spray. I'll do the same on the next one down. Give it a good spray. I'll close this thing up and I'll grab the knob here and I'll just start back and forth, all the way back and forth. And that stuff works miracles in there. Similarly, I'll come over here and get it aimed in here and give it a good spray. Come over here on this side, back and forth. A lot of times you can feel these things loosen up as you're turning them because they're just gummed up after years of use. And I'll come in here and turn this one back and forth. Come here, Jack. Oh, my trusty companion here. He's happy to see me. Australian Shepherd. His name's Jack, and he is 3 years old. He's got a sister who is a female Australian Shepherd named Lucy, and she's about half his size. This is an 85-pound Australian Shepherd. He gives me lots of love. At any rate, I've gotten that one. Now I've got one more down here. And if you'll notice, there's two sides to these. Some of these, they're called ganged. One on the top and one on the bottom. And usually that's left channel, right channel type thing when you see that. So you got to get both sides of it. And reach over here. A lot of times there'll just be one knob, but it's turning both parts of the ganged potentiometer. And that should do it. The only other thing I'm going to hit is right here. We've got a switch control. And the I'll turn this thing on and off a few times just to kind of get the contacts in there. And you can't see what I'm doing because I'm moving around too much. But there we go. Get that switch working really well. I'm going to put it back together and then I'll show you what I'm going to do with the rest of this thing. Starts getting into more mechanical things. I'm an electrical engineer by education. Not a mechanical engineer, but hey, I can wing it. All right. We've now got the cover back on, the two screws that held the cover, and a little metal ground piece here that holds these wires in place. But what I want to do next is test these tubes. And if you'll notice here, if you can read upside down, it says this amplifier uses two 60FX5 tubes. So I'm going to pull the two tubes out of their sockets. And we're going to take these over here. And I have plugged up my handy dandy, if you can see here, it is a TV7D/U. Really nice tube tester that I've had for a long time. And I use it a lot. Anyway, got it turned on because inside of this there's two tubes. There's a type 80 and then another tube in there that have to warm up themselves as part of the supplying the high voltage for this. So I come over here and what was that again? 60, you can barely see here on the edge of the tube. 60FX5. And I'm going to look in my handy dandy little manual that came with this thing from probably around January 1962. Department of the Navy. These things were all, these tube testers were all military based, based on the Hickok design. So 60FX5. What it tells me is here, 50 filament volts. So I come over here and I grab my little knob and I pull it over. This is where you set the filament voltage. Most of the time you're testing tubes, it's either 6.3 or 12, sometimes 2.5 for some older single-ended tubes. But I'm going to crank this thing over here all the way up to 50 volts. And then we're going to go over here and it says settings are ET27610. So the way that works is you start here at the top and it's E, and then you turn this one to T, and then you come over here and you turn this to 2, and it was ET27610. 7610. And if you notice the way these things are labeled, what you're really telling it is on this tube, you know, the pin numbers go 1, 2, 3, 4, 5, 6, 7 on this one, going around, and they'll go into this 7-pin socket right here. But what you're telling it is pin, the filament, you're actually telling it which pins they're on. So it tells you the 2 for the filament, tells you the grid is on pin 2, plate is on pin 7, screen is on pin 6, cathode is on pin 1, and there is no suppressor or secondary grid. Screen sometimes called. And then if we look back up here, it tells me the bias goes to 15 and there's no shunt. So bias setting here, I'll turn it down to 15, just like that. Shunt is 0. Come back up here, it tells me I'm going to set on range D, and I'll put it as 3. See up here, you can see here. It tells me range D, and press 3 to test, and minimum value of 31. So over here's your ranges. It's going to go on D, and then we'll be pressing 3 right here to show the mutual conductance. So what we're going to do is plug the little tube in. Over here, you got to get it lined up. There's always one missing pin on the bottom of a tube, as you can see, which is called the key, same as on this socket. You'll put it in there and kind of wiggle it down in there good and tight. And that tube should start glowing here in just a second. It's kind of hard to see inside of this one, but sure enough it is. And the next thing you'll do is you'll come over here to what's called this little button here on the very bottom called line adjust, if you can see it. And what you do is you hold it down until you see how the line's to the left of the center. And boy, I'm going to have a hard time doing this with one hand here. But basically there's a knob over here on the other side, and you're going to adjust it until that line is square up in the center. So I would be doing it while I'm pushing the button. I just don't have 3 hands, and that's pretty spot on right there. So what that does is it checks the line voltage coming into the thing. It takes away the voltage or any drop coming from heating up the heaters in this thing, and it basically gives the right parameters to the tube for testing. So that thing should be heated up by now, and we're going to push the button over here called mutual conductance. And if you'll notice, we are reading 50. So minimum value was 31, so this is 50. The way I usually mark these is I'll go to the tube and I'll write on it 50/31. So I know 31 is minimum. I know this one was at a 50, and I'll show you that. So I've written it on here, and boy, is it hard to see here. But as I scroll it, you can see it says 50/31. And then what that tells me is where it stands relative to the minimum value. And I just use a little Sharpie. Always write it on the bottom of the tube below the branding or whatnot. And in the meantime, I'll plug this in and letting it start to warm up. These 7-pin tubes are just pretty simple tubes. A lot of the 9-pin tubes, there's actually 2 tubes inside of one, so you have to set all your settings, test one half the tube, change some settings here, test the other half of the tube. At any rate, I shouldn't have to check the line voltage again because it's spot on. Usually going from tube to tube, as long as it's the same type tube, you don't have to change the line test again. But this thing's heating up, and let's see where it's at. Oh, this one's testing at a 58. So we'll come over here and mark this one down as a 58. So here's what I'm thinking. They're not balanced, but this is not a balanced amplifier. This is 2 single-ended amplifiers in this thing. And if you'll notice, one of them, the red wires here for this one, this is a transformer here on the out. It's an output transformer. It's feeding this speaker right here. And if you'll notice the other one here, which is coming off of this other tube, is feeding this, which goes to the external speaker, which is actually mounted inside of this little cabinet here. So it's a little bit bigger speaker. So what I'm going to do is I'm going to feed the bigger speaker with the tube that's a little stronger. I will go down in the building one day and see if I've got a pair of these that match up a little closer. Both of them are in great shape. Both of them are working great. One might just be slightly louder than the other where they stand today. So this 58, I'm going to put it back into this socket here. And sometimes hang on one second. Just knowing that these tube sockets are approaching 60 years old at this point, I'm going to, just some good old contact cleaner that you can get at anywhere, AutoZone or Advance or any of your favorite auto parts or any of your big box retailers, Walmart or whatnot carry it. Just spray a little bit on these pins. So as I insert this back in, kind of cleans the pin sockets up just a little bit. In case there's any corrosion starting or anything like that, it's just a good practice. All right, got that back in there. Let me throw this thing back together and turn it on and see how it sounds. All right, a couple things I'm noticing here. Let me see if I can demonstrate some of them. Turn this thing on. And if you'll notice, we got some hum coming in, but it's not from the power supply anymore. If you come over here, anywhere I touch metal on this thing, I'm getting a hum. Yeah, you know what that's telling me? I got a grounding issue somewhere in this. And also I don't have a cartridge installed, so it could be part of that, but likely I've got a grounding issue somewhere here, either with the, yeah, notice when I touch these speaker wires, not the speaker wires, the tone arm cables, I get lots and lots of pop in here. So anyway, I got to chase that down. It's a grounding issue. The other thing, I was getting ready to pull this idler. This is an idler wheel here, and I'm going to pull it off and hopefully find a new one and put it on there, because these things just get extremely hard over time. But when I do get ready to put a new one back on it, I'm going to lubricate this thing. Let me show you what I'm going to use. You see these little bottles like this sold on eBay all the time for about 10 or 12 bucks. And they're usually labeled like AR turntable oil, or Lin turntable oil, or Rega turntable oil. And what they're doing is people buy these bottles up by the hundreds, and they basically fill them up with oil, and then they stick a sticker on them, and they make you think they're special for your turntable, but they're not. So I'm going to do the Blueglow version of Mythbusters here today, per se. And I'm going to show you what those guys are really selling inside of those little bottles. By the way, you can get 2 of these bottles for $2.99 shipped to you. If you just need a couple for around the house, check eBay. Search for needle oiler or needle bottle is what you'll find. And it's just got a little metal needle here with a hole in the middle of it that lets you put oil in places very gently. But here is the secret. And I don't care what brand. They are basically using synthetic motor oil, and they're using an extremely light version of it. Either 0W30 or maybe 5W30 is what's actually being used in those things most of the time. So let's see, this was a $5 or $6 for this thing. It'll probably fill up about maybe about 15 of these. So $6. And if you bought 10 of these or 15 of them, you'd probably have $10. So you'd have $15 and 15 of these, so $1 each. And then you can sell them on eBay for $10 a piece, and that'd be $150 minus the $15. That's a $135 profit. So don't tell anybody I haven't told you how to make money along the way. But anyway, I just wanted to show you that. I'm going to dig into this thing a little more. I've actually ordered a new cartridge head shell up here. So when it comes in, we'll put that on. I'll chase down this grounding issue. Probably end up having to take this this turntable section out altogether. But we'll get to the bottom of it. All right. So what we're doing is we're deviating a little bit away from the electronics, which is what most of my videos are about. But got into some mechanical stuff, which you get into with turntables, with reel-to-reel players, cassette decks. You know, a lot of people ask me what's the hardest thing to work on, and you know, to be honest, VCRs were the hardest thing to ever work on. There's just lots of moving parts in there, mechanical, lots of sensors, trips, whatnot, and then you had the electrical side of them at the same time. So never have gone to school for mechanical engineering. I have for electrical, but you know, we spent my entire life working on cars and vehicles and motorcycles and whatnot, so I've been fairly mechanically inclined. Had to remove 4 screws here and drop down the motor, and I had to lift one end of the plinth up. And what that enabled me to do, along with moving a few other key little springs and clips here, is it let me get this little part off. And what this part is, let me find the other piece here. Alright, so you got a couple pieces here to how these old tables worked. So first off, you had this is your platter that's, you know, the record sits on and it spins, right? Well, inside of the platter, the way this thing works, there's no belt on these units. If you'll notice, going around the inside here, all the way around, there's pretty good ring worn, going all the way around. And then, believe it or not, this platter is copper. It's made to be that way because it's heavy, and copper doesn't, kind of dampens the sound a little bit. So got this worn spot around, and what happens is you got this idler wheel, and so what happens is I've got it all upside down right now because this would be sitting down inside of here like this. So the motor shaft, which you can barely see down in there, that little bitty thing right there that spins, that thing turns, and what it does is this spring right here, really heavy spring, when you engage it, you can see it moves. It puts pressure on this little round wheel right here against that motor, and it starts on a shaft. It starts spinning this thing round and round and round. And if you'll notice, that thing's sitting up. You drop the platter down on this, what happens is, in essence, this thing gets crammed by that spring up against the edge here, and you can see the idler down here actually spins, and what it does is it runs against this platter and causes it to turn. But if you hear the little noise, I'm just rubbing this back and forth. It's fairly rough. Do you want to know why it's rough? Because this thing is 60 years old, and it is as hard, it's rubber, but it is hard as this metal. It is basically dry rotted. It's not falling apart, but it is extremely tough. And if you try to get it to bend and give any flexibility, it would just snap and break. So what I've got to do, this thing, when the turntable spins, you can hear it. Kind of a grinding sound. And what it is this wheel going up against this, spinning, and there's no dampening here coming from the rubber, which should be happening to kind of cut the sound down from this. So I'm going to have to either try to find one of these, which I'm just going to tell you it's pretty darn near impossible, and here's why. Because no one has ever made new ones. So even if you found one new in the bag from 1958 or whenever this unit was made, the one sitting in the bag will be as hard as this one is. So, so new old stock means nothing when it comes to rubber items. So what I'm going to end up having to do is I'm going to take you over to my computer real quick and I'll show you. Well, what we have got our idler sitting here, and put it on the white paper so you can see it really well. And this white paper happens to be my grocery list. Most people, you know, they have ice cream, potato chips, bread, milk, whatnot on their grocery list. I've got a whole pile of capacitors that I'm starting to run low on. But at any rate, what I really wanted to show you was up here. This guy here, Ken's Electronics, looks like he's out of Kalamazoo, Michigan. And if you start scrolling down on his page, sooner or later, through his idler wheels, you will come down to one. I haven't quite found it right here. If you'll notice, this $14.99 37 doubler idler, I'm going to have to measure these holes to make sure it's right. And it was part of the used in Webcor units, as you can see right here. And the way this guy works is you send him in your old one, and he sends you back a new one for $42. And he says here he has them in stock for prompt shipment after you have sent in your dud trade-in. So I'm going to spend 42 bucks, a little more, mail this thing in, and get a new one. I'm going to measure the holes on this thing, make sure it's exactly right. And if it is, then we'll ship it in. There is another one, if you scroll down a little bit, that looks just, basically I started with the pictures, but if you'll notice there's another one here. It's also used on Webcor. Has a smaller hole in the center here. So I have to figure out the exact size of this hole and kind of take it from there. But either way, both of them are $42, and probably take a week or two to get one back in here for me. I'm still waiting on the stylus and cartridge for this thing anyway, so that's the name of the game. A lot of times, you do some work and then you have to sit and wait on parts, and then when the parts kind of show back up, you can kind of go from there. And I'm going to take you back over the other side. Okay, we're just measuring this thing, and you can see here this thing is 1, 2, 3 sixteenths across. You do the math, divide 3 into 16ths, and you get 0.1875. And if you notice, the smaller one that he sells here is 0.188 center hole, which is about spot on for this thing. I also measured the bottom, and it was 1 3/16. I measured the height, it was 15/16. But then it's funny, it says here the small upper part is 13/16. And if I come back down here and measure this thing, shows up, it's hard to get, see until I get it. This thing is 3/4 in size. So it's a 1/16 inch smaller, and I'll tell you why that is. It's because this thing, one, is as it's gotten hard, it's shrunk some. Two, it is worn off that much. You can see how it's kind of worn around on the edges of this thing. So we're going to go ahead and get this thing ordered. The one it needs here is this 149201 double idler. And let you know when it gets in, and we'll kind of finish this thing up. Welcome back. It's been about 2 weeks since I've done any work on this, mainly because I was waiting on some parts to come in. So the first one that came in this nice little package here is the Ronat 208 cartridge with 2 new styluses on it that I've installed. And we'll be showing you how to install that. It will basically come up here and install inside the head shell. If you'll notice here on the head shell itself, there's this little knob here that turns, and it basically flips the cartridge over to the other side to use the other needle. And what happens here on one end, it's very hard to see, but maybe you can see it there. There's actually a little pin through here, and it goes straight through this thing. What it ends up doing is holding this unit. You can see the pin and the pinhole in this thing. It holds this unit up in here. So once I get that out, then basically this unit will drop down. These 4 little connectors here, called tags usually, connect to the actual tone arm wires, and then they will plug on to the back of the cartridge itself. So we're going to be doing this today. The other thing is, if you'll remember, down inside this hole here was where the motor mounted, and there was some spindles here. And on one of those spindles was the idler arm. And if you remember, I had to send the idler arm off for repair. So right here is a brand new refurbished idler arm. Nice rubber that's got some flexibility to it now. Before it was just brittle. And this guy here, let's send his card along, kenselectronics.com, does rebuilds these things. Not exactly cheap, but the reality is, what other choice do you have? Because like I mentioned before, even if you found a new old stock one of these in the box, it's likely to be dried out and hard and not functional as well. And if you remember, part of this goes down inside the actual motor hole there, and the motor spindle turns it. And then the other part here actually spins, and as it spins, it basically turns the platter, if you'll remember, that the record sits on. So we're going to try to get these installed this morning, show you how I do that, and hopefully get this thing running I'm sure we could find some other things along the way, but that's the intent as of right now. One more thing I meant to tell you about before I dive in. This is a what's called a Sam's PhotoFact folder. And Sam's has been doing this for ages. This one's from 1962. If you'll notice here, 1162, but they actually go back further than that. And originally they started out as just little folders here that told you a little bit about it. If you'll notice, the cover shows you a nice picture, describes a little bit about it, where it was manufactured and whatnot, and the various models that this actual PhotoFact covers. Flip it over on the inside, you'll notice you have a nice schematic here that tells you everything you need to know about things. And it also gives you some reference points. So I'll give you an example. Right here you'll see 6. Well, you come over here at 6 and it'll tell you some resistance to ground numbers for you to actually check out to let you know everything about the circuit's good. It's just a nice set of readings so you can kind of go through the schematic from one end to the other, and it'll tell you if anything's really out of whack. The other thing it has here is a nice picture of the inside of the tube amp itself, and it shows you where all the various parts are. And if you'll remember, this was the part I went in and replaced all the capacitors and whatnot. And then typically on the back here, it gives you a nice, you can see, parts list, breakdown, description that originally came with these things. And I've made some notes here on the idler wheel and a few different things, but these are very handy little Sam's PhotoFact folders. Later on, say you get on up towards the 70s, and these folders actually became books. They were doing full documentation books on units. I've seen them for a lot of ham radio gear, various electronics and whatnot, but they got much thicker as time went on. But I picked this up along the way mainly because I knew I was going to need to order some parts and things, and I was going to need to know part numbers that were specific for this unit. It's very helpful. Usually a folder like this will cost you $5 shipped or so, and there are places online that have all of these stored online. You can actually go to the Sam's site and pay money and actually download them as PDFs instead. I picked this one up off of eBay for just a couple bucks, so I went that route, but could have gone the other route as well. The reason I did this is I thought I would, I'd put this back in the unit and give it to the customer. So if they ever have to have it serviced in the future, they'll have this nice little handy sheet to go with it. Alright, first thing I'm doing here is the shaft that the idler actually rides upon. It was a little bit rusty along here and had some residue built up on it. So I started off by knocking it off with just a little bit of this mesh sandpaper, and then I used some sandpaper here to kind of polish it fairly smooth. Just want to show you that. One more thing I did before I get ready to put this back together. This little shaft that the idler spins on is very, very important that it doesn't produce any noise, because it basically hits the great big copper platter here and resonates any sounds that it makes. So what I've done here is just a little old Dremel tool, to any Dremel will work, with a round, soft felt polishing wheel. And I'm using a little bit of this stuff here, Winol. I use it all the time with my larger polishing wheel. What I've done is put a little bit on this, and I basically polish this thing until it's pretty much shiny like mirror finish. Just trying to get the idler spinning on this thing as smoothly as possible. Alright. We've got the new idler mounted down in here. Got the spring put in place that holds tension down on this. Got the little movement arm here that kind of tracks back and forth as to the auto disengage of the arm or whatnot. Got this spindle all cleaned up and oiled up, and I'm ready to drop this plotter back down on here and see how it plays. Alright. got the little C-clip attached here, got the platter back down on it, got it plugged in, and let's reach over here and turn it on. Wow. Can't remember if I made a video of how it sounded before, but it was horrible. It was this real rough sound, just kind of grinding all the time. Most of it comes because that little idler wheel here that attached down to the motor was just extremely hard and dried up, and so it was taking the motor noise and transferring it straight to the edge of this platter. So that idler wheel, if you remember, is sitting about right here, just spinning round and round and round and spinning this outer platter. But you know, as I go to put pressure on this thing, it's got a good solid, it would take a lot to stop it. So I'll reach over here and change the speed to, say, 78. It's going much faster now. I'll drop it down a notch at 45. It's moving just right. Then let's play then at 33. And down at 16. I didn't show you what causes that, but what it is the idler wheel, as you move this, moves up and down. There's a little set of stair steps there attached to a lever here. And as you turn this dial, it pushes the stair steps back and forth, raises up or down the idler. And then the shaft on the motor has 4 different positions. A big one that turns it at 16. A little bit littler one that does 33, a little bit smaller one at 45, and then finally the last one at 78. So it really just changes the ratio, gear ratio, between the drive shaft on the motor and the actual the idler wheel here. So I'm going to go ahead and get this head shield cartridge changed and see how this thing sounds. Alright, got the new idler installed in this thing, and as you can see, I've got the table kind of propped up here, suspended a little bit. I'm having some challenges with the actual movement mechanism, but as far as turning the turntable on, you'll notice the record is spinning extremely quiet. You come over here and drop the needle down.
Walking like a man.
The unit is sounding amazing. The issue I've got is actually right now, when I hit the reject button, it'll come along, reject it, which it should. Then it starts the next record, but when on 33, it's going over to the 45 spot. So gotta figure out what's causing that and see if I can get that straightened out. Well, I'd like to apologize for skipping some steps on the video, but this thing got pretty deep in and had some issues with it. But we finally got it going. I'm going to show you now what all I did to it. So first off, you can kind of see I've got the turntable portion here kind of suspended up in the air. As you can see, just kind of instead of drop down inside the thing, I've got it suspended up here, and that was so I could get up underneath it and watch the mechanisms as it worked and as it did its thing. So a couple things I want to show you here, if I can get to it here. Hang on one second. First off, we got the tube out finished up. I did order a brand new set of tubes here for this thing, a matched pair. One of the things I found was that the two that were originally in it here were not really balanced. One was in really good shape and the other one was fairly weak, and it causes hum in these things. Not like hum as if you know, capacitor type hum or whatnot. It creates a louder sense of noise in the unit than I really wanted. So I replaced those, and then kind of got this all bolted back together and put back in, and then this just basically drops back up in here, and we'll screw in and tighten up. We actually, let me get this off of here. Actually got the idler back on. If you'll remember, it went underneath here, and I'm not sure if you can see it, but it's the little wheel. I'll point to it right here that my finger's on that I'm spinning. Got it mounted back in there properly, and then we clean the entire mechanism. And underneath of these things is a big long section that goes from about here all the way to the back side. I'll see if I can move around. Turn a little bit of light on, but you can see this whole unit, big long black arm that goes from the motor over there all the way back here to the turn arm section. That is considered the transmission of this unit, and we basically had to clean that entire unit, and I used a bunch of as you can see here, just old Q-tips. I probably used 15 or 20 of them. You can see them kind of laying everywhere here, and I kind of degunked this thing from one end to the other, and then I used just some plain old white lithium grease to replace back in there on the moving parts. So we kind of got the whole unit set up here. Let me give you a demonstration here real quick, if I can. So I'm going to set this record up, and it's important that it sits up on the top when you start this thing, the way these units work. So you will basically then make sure you got it set here on 33, and you'll basically grab this unit and push it back till past the on section to the reject. And if you'll notice, once you do that, the tone arm lifts up, the arm drops down, it moves this little sensor, which tells it to stop at the 33 position. And then
How fast me a train I see. I got the blues on this so-and-so, and it's all got the blues about me.
it's just an old Robert Johnson Delta Blues record that I use for testing a lot of these record players and whatnot. It had plenty of scratches to begin with, so it doesn't hurt to get a few more. And when the record gets to the very end, because this lever is down, it'll do the eject, it'll take it back over, and it should just drop it down at that point. If this arm had been up, it would have dropped the next record and moved the arm back over. And I'll give you a demonstration of that. Hang on one second. Okay. What we've got now is a couple 45s, two of them, a yellow one here and a blue one here. And on the back, if you'll notice this little lever, so when the tone arm lifts up, and then, let me turn this light off over here. Tone arm lifts up here, and then the first record drops, it will not hit that lever, and that'll indicate for the arm to actually come over to the 45 spot and start playing. So we'll do the same thing here. We'll reach down. Oh, I need to change it over to 45. Oh yeah, one other thing real quick. The needle here, it's set on 33/45. You can actually turn this, you can see here. You can turn this over to the other side. And then you've got the 78 needle available for play. So anyway, we'll set it back down. I was just showing you that that needle can move from one side to the other, but we got it on 30, nope. We've got it on 45. We're going to hit the button. Lifts the arm. First record drops. Music drops over and starts playing. gets to the end here, it'll run out, trip the lever, it'll move over, drop the second record.
Shadow I cast is a thinner version. Faded frame of a familiar person.
This is actually a local band here, and this record's actually on my own record label. I've got a record label called Grimtail Records, and I've been putting out records for a couple of years, 45s of a lot of local bands and whatnot. So, anyway, we'll pretend it gets to the end here, and we'll lift up, go over, and because this arm's down, it will turn off the unit. Alright, I'm going to drop this whole unit back in, get it cleaned up just a little bit, and come back and show you it working with it in place. Got the unit put back together. I still got the screws to put in it, but thought I'd make sure it was working here properly. As you can see, I got the table mounted back down in here. Plug the little power cord here in. Just FYI, I'm getting these things out on the front here. Below this screw on the bottom is a little latch that's flat, and you basically turn it straight up, and then you push the table down, turn the latch at the bottom of it kind of straight up, and it lets this end lift out. This back does not have the same latch, but there's actually a groove, a square groove cut in to the board back here. And so if you grab the whole unit here by the spindle and maybe support it with your hand, the whole thing just kind of slides out and up this way, and to pull this whole unit out, just in case you're wondering. It took me a few minutes to figure that out. At any rate, I'm going to pop this thing loose here. We are going to see, it's set right now on 78. That would not be good. We got it on 45, and let's push it over here. Drop the record, brought it over, dropped it. Take a minute for the tubes to warm up in this thing. It'll lift it, it'll drop the next one, drop it down.
Is a thinner version. Faded frame of a familiar person. Let's go. Wow.
Well, we finally got this thing wrapped up. Got the secondary speaker hooked up here. I don't know if you noticed, it just kind of plugs in here, and then the cord goes back into the body of it a little bit. And you got volume 1, which is this speaker, volume 2, which is over here. And you can pick this up and move it across the room. That cord's pretty long. Anyways, right here we've got a Donald Byrd Blue Note LP. And if you notice, I've got it set up and ready for the automatic changer. I'm going to go down here and hit the on button, hit it over to reject, which causes it to start the motion, drops the table, drops it down. Sounding really good. You know, a couple things about these Webcor units. They, you know, this was hi-fi in the late 50s, so while it's good quality stuff and will last a lifetime with just a little bit of maintenance like we've done here, you know, it just, they are what they are. They were, I'm not gonna say they were made cheap, but they were certainly made to be an inexpensive portable turntable that you could carry around and do things with. Very different than a modern stereo setup. But you know, if you're into nostalgia and like the vintage look and want something you can just sit around your house and listen to, great little units. Probably outlast my lifetime. And like I say, just amazing little units to have done upright, and it's good to see something like this restored and kind of brought back to life instead of ending up in a landfill where most of these types of things would end up. So really excited about this. I want to show you a 45 drop in here and let you see how that works, and we'll wrap this video up then. Just a couple more things as I'm wrapping up the video here on this types of units. These old Webcors and many others like this that were tube based units, they have something that is called a hot chassis. It's something that modern day electrical code UL listings would not allow, but it was very popular back in the 50s. And without getting into a ton of details on electronics, the basic premise is, you know, it uses a two-prong power cord, and the ground on the chassis here is different than earth ground. So just a hint about them. Sometimes when you touch the chassis or even the tone arm, if you're standing on, like, say, bare concrete with no shoes on, you'll feel just a slightest little tingle, and it's actually current flowing through your body. So one of the things I'd always recommend when operating one of these is to wear shoes, stand on carpet. Basically, don't turn yourself into a great big ground. Oh, Sadie came to visit us. Hey, girl. Good morning, my German Shepherd, who normally lives outside, but we've had a week of snow and ice, so she came to see me, and she's getting pretty old, about 13 years old now. So, at any rate, I was going to show you the confidence I have in this thing at this point in time. This is a record by the Nomads on Tornado record label called Thoughts of a Madman, and it's something I picked up a couple weeks ago in a trade, but it's one of the top 100 rarest garage garage records from the 60s. If any of you guys follow the G45 website, where they have all the top garage 45 collectors hang out, it's in their top 100 list. A pretty scarce record. It was actually made in Mount Airy, North Carolina, which is about 20 minutes from my house. So yeah, probably only, I don't know, a couple dozen maybe or less, dozen or two known to exist at this point in time. But I thought we would see how this thing played. If you notice the center spindle that I've snapped down on here, it's designed to hold large hole 45s. Here we go.
Have them take all my toys away, and never did all seem to say that I'll roll in my coffin made of gray. Thoughts of a madman seem to say that I'll have to die someday. Cross my mind, almost more the thoughts in my wine. Nothing in the whole world seems so fine as to die and find.
So I'll show you how the reject function worked. Now, if there had been another 45 on here and this lever had been up, it would have then dropped the second 45 and started playing it at that point. It's not until it runs out of records and this little arm here actually goes down to this level that it would return the arm back over to the center spot. Another thing, there's a little notch right here, and underneath here there's two little metal things that you can snap this down. So for transport or whatnot, it's kind of locked down at that point in time. And the chassis itself floats a little bit here, you can see. It's got a spring set up here, here, and 4 springs on the corners. When you go to travel, you can take these screws here and screw them down and it locks the table down hard, so you don't have the thing bouncing around the whole time. At any rate, beautiful little turntable setup. Really happy with how it worked out. Ooh, if you notice, it pops up even off of the little thing here. Yeah. If I take that arm and move it back like this and do the same procedure, it'll think there's a record on there. It'll attempt to drop it, but it's already dropped. So it'll go over, it'll drop down, and why is it going back? Because the arm is up. It'll recognize and come over here. The way it tells the difference between a 33 LP and a small 45 is when the record drops down, if it pushes this back, it knows it's a 33, and then it'll only move over just a little bit. You can confuse these types of tables a little bit. Let's say you've got a modern 7-inch record that has 4 songs on it. Maybe it's an EP, but instead of playing at 45, it plays at 33. In that case, you don't hit the reject button up here. You just kind of turn it to the speed you want. You kind of turn it on, and then you manually do everything at that point. In other words. All right, guys, gals, thanks for watching. Hope you enjoyed this. Quite a long, lengthy restore on this thing, but had a lot of fun making the video, and hopefully this thing's headed back to the lady that brought it to me here in the next week or so. And as you can see, it closes up into a nice, neat little unit here. Pretty neat. Thanks again. We'll see you again in the next video.